All right, let's talk about the graphs of inverses real quick. The graphs of inverse are going to reflect, and they're going to reflect pretty evenly. But they say, first of all, they say find the inverse of the function, then graph it at its and the inverse. So let's start off with finding the inverse. So again, first things first, switch x and y. X equals -1. Let's zoom in. X equals -1/5 y minus 1. We move the 1 over. That's x plus 1 equals -1/5 y. The way you get rid of a 1/5 is by multiplying by -5. So multiply both sides by -5. And I get -5x minus 5 equals y. Alright, so that's our inverse. Right there. That's your f -1 of x. Right? Then they tell us to graph both of them, which, if you remember how to graph, y-intercept, -1. I'll start off by... Oh, stop it. My iPad is not cooperating with me. Here we go. So, -1. And then your slope is -1/5. So that's rise or run. Up 1 over 5th, but in the negative direction. So up 1, 2, 3, 4, 5, left 5. Or you could have gone down 1, 2, 3, 4, 5 to the right, and that would have given you that one. So this line looks kind of like that. Cool. The other one, your y-intercept, is again the one that's all by itself. So that's -5. And the slope is 5, and -5 that is, and we're going to put it over 1. So it's up 5, left 1, up 5, left 1. And so you get a line that looks like that. Alright, I can't use a straight edge on this computer, so there, on this program. Alright, so those are the two lines. Now, here's the issue. They don't reflect across the x-axis. They don't reflect across the y-axis. They actually reflect across this line right here. If you were to turn this, rotate your phone or screen sideways 45 degrees to where the orange line is horizontal, and then look at it, and you'll notice that the lines are perfect mirrors over each other. Okay? If you were to tilt your screen 45 degrees to the right, you'll notice those are perfect mirrors over each other. And this is the line y equals x. So, to answer question number 7, inverse functions reflect across what line? Y equals x. And that's a very simple line. It's actually your linear parent function. So if we were to ask this on a question, wink, wink, nudge, nudge, say no more, you could put either one of these. Answers, and it would be considered right. They reflect across the line y equals x. All right, number 6, same idea. So we'll switch the variables. So x equals 3/4 y plus 3. Subtract your 3, x minus 3 equals 3/4 y. And then when you're dealing with a fraction, remember you just flip it. So that's 4/3 times 4/3. And I can write that as 4, let's get the right color. That's 4/3 x. 3 times 4/3 is simply 4, minus 4 equals y. So let's put our lines up there again. Alright, so for the first one, we've got a y-intercept of 3 and a slope of 3/4. Y-intercept of 3 and a slope of 3/4. And it's positive, so I can't go up 3, so I'll go down 1, 2, 3, and I'll go 4 to the left in order to make the slope go the right direction. Okay? And the other one is -4/4, so that's our y-intercept. Used red, didn't I? -4. And a slope of 4/3. 1, 2, 3, 4, 1, 2, 3. And it'll go like that. And again, if you draw your line y equals x, which you don't have to on a test or anything like that, it'll come off it. And turn it 45 degrees right, you'll realize those really are mirror images of each other across that line. So that's how we do with graphs. C'est la vie.